we were going to discuss the Emmy Awards and Nominees, and we were going to make a machine learning model using BAC3 and XGBoost machine learning models to analyze which categories could be nominated and for an award, and which categories could have been won. And we were going to do some personal component analysis and so PCA and some other stuff. So let's see the database. This is our database on which we will be working. It's mainly categorical, we'll see. So database can be found. Let us see here, nominees, okay. Let us see it row, view row. Okay, this will be our database, okay. Let us start, don't save, okay. Yes, okay. So this is our studio, the main thing we'll be using. Let's start the project and see where it will go. New file, new project, R markdown, okay. We won't be needing this stuff. Let us give new chunk, library tidy, where's the first library we'll need. The second library is tidy models. Library tidy models. Okay, I like adding library library scales, library date, library text recipes. Okay, and I like to do set team set set. Okay, let's start these things so we can have this function, and okay, and let's give that we want chunk output in console, remove. Okay, this is the libraries we'll be using. So tidyverse and tidymodel are vignettes of bigger of other libraries, for example ggplot and dplyr, which we'll be using for our modeling analysis. So team set, let's set our team to gg teams team clean. I like this theme, and we'll do some parallel processing for modeling. So if you want it be fast, do parallel. Okay, register do parallel, and here I have 8 cores on my machine. Cores cores 8. Okay, this is the only things we need. Okay. And let's start exploring our database. So our database will be, okay, let us see, this is our database, okay, globe, read CSV function and our database. This is our database. Okay, before understanding what we have our database, and if we don't have much time, I like to use scheme R function, scheme, to understand what we have in our database, globe. Okay, as we can see, it's 1 minute, please. It's okay. Let us see what we have. Do another things. Okay. Globe count. Okay. Let us see why it's not doing. It's right now calculating like the function I have read. It's just downloading the main database from the internet. That's why it's taking some time. Let us wait a minute. Wait a minute. Before it is downloaded, let us see what we have in our database. Okay, as we can see, we have category, our category, logo, which we won't be using because I've seen what is in this database, and it's just hyperlinks. Production type, this is the main thing, nominee or winner, we are going to analyze and predict. Machine learning, title, distributor, producer, year. I don't think we are going to use year because it's not a good predictor in this case, but we'll see. Okay, as you can see, it's downloaded, and this function gave us a result. So it skimmed our database. We can see in this database there are 7 characters and 3 numeric variables. And since these 7 characteristic variables, we have the type, which has only 2 and unique, so winner or loser, and category, logo, and other stuff. I like to count, so this is one of most useful functions we can use. And let's count some things. Let's count type. I know there are 2 types, so nominee, we have so much nominees, and winners, we have quite a few winners. And let's see other things. So let us first of all see category, what we have in category. As you can see, let's sort, so or equals true, let's write, and as you can see there are reached sort equals true. Okay, give me the first, please. It's doing something. Okay, let us do it. Globe, let us table. Okay, add a new function, then like this. Okay, as we can see, there is in category, there is the category, and there is year. We don't need year for the year for prediction, and we have a year column as well, year column as well. So you can see it starts. This year is in this category, so we have some repetition of data. So I want to extract from category. Let's say into 2 columns. Let's say category and year dot new, something like that. And say let's write regex, which will be equal to let us see, we have some words. Okay, it goes, and then we have dash, and this thing is the thing we are interested in. Then we have the date, so we'll write it like this, date, and something like that. And I will select convert equals true. Let us see, and okay, this is the new category we'll have. Okay, new column we'll have. Let us see what we'll get. Okay, there is some errors, as we can see. Okay, day group. Okay, group found. Let me see. Okay, extract here new. Okay, this is the problem. Okay, NA, that's fine. That is fine. Okay, as you can see, we have extracted some things from here, so only the category without the year. And if we look at the year, so year new, there is a new column called year new, and here they are quite the same, sort through. Okay, the same column, so we can disregard this column because it's a representation of data, and write it like this. So category, we only have the category. Okay, category. Category. Let's see the regex. Must group by variable found in data, column category. Category. Okay. Category. Okay, we have this column. Okay, let's see what else we can do, because before we start machine learning and some stuff, let us I don't know, let us go through make some visualizations. Let us make some visualizations. Okay. Okay, this will be globe clean. We cleaned a bit our database. Okay, let us go globe clean. Okay, let's select is numeric. So all our numeric predictors, and type, the only thing we are going to predict on. Let's say pivot longer. Let's do pivot longer. Before I do pivot longer, let's see what we have. So as you can see, we only selected our three numeric variables which we have, and the type. And what I want to see is how our numeric variables affect the type. If we want I want to see how much our numeric variables are how well our numeric variables can predict. So pivot longer, and pivot longer will do is numeric. So everything that is numeric will be pivoted. So let us see what we have. So name, year, page ID was pivoted. This will ggplot help us make a visualization. Aesthetics, x is our value. Okay, fill is type. Okay, we must facet wrap. Okay, facet wrap by name, and scales equals 3, and we are going to write a geom density. Okay, with alpha. No, okay, let us see what we have. Okay, as you can see, there is not much predictive power from our numerical variables. This is page, so page has some predictive power. If it's from null to 500, it is more possible. The possibility that it will be just a nominee is higher, and if it has from 500 to 1000 pages, the probability that it will be a winner is higher. So there is some predictive power here. It just says that in from 2000 to 2010 there were more winners among all the candidates, and from 2010 there were more nominees than winners. I don't know what is page ID, but we'll see what we can do in our predictions. The other things we can do is to to use some let's see, some categorical variables to see how much those categorical variables affect our prediction. So we have distributor and producer, and in a lot of cases, ABC, as you can see, is the same thing, hula, but I don't know how much they are the same thing, but we can see how much the distributor and producer affect our winning probability. So let us first of all see how much are they the same. So let's mutate and say that I don't know, let's condition on dt on is equal to if distributor, there's three distributor and producer we need. If distributor is producer, so if distributor equals to producer, and let's count condition. Okay, and as you can see, and in majority of cases, these two aren't the same, ABC. So in there, it is the same in, I don't know, let's say mutate, let's summarize, and say PCT equals n sum n. Okay, in 95% cases is this the same, and in only 5% cases they in 5% cases they are the same, and only in 95% cases they differ, something like that. Okay, let's continue. So let's have glob clean, and let's mutate it. Mutate and say we have a lot of distributors, quite a lot. Let's pick the top 20 or top 20 is fine. So we'll do factor lump, so it will be lumped distributor. Okay, and say n equals 20. The same thing we'll do with producer. Producer equals to factor lump producer n equals 20. Okay, and let's filter other, because we'll have other. Let's see. Let's count first of all to get to be sure. Okay, distributor. Okay, and sort equals true. Okay. Okay, it's doing some stuff. It's quite slow right now. Maybe. Okay, facet lamp. Okay, let's write some code as it's showing at the stuff. I want it to. Okay. Why? Okay, it's done all the code. Okay. That's why it's slow, because it's done all the chunk. Okay. It's run all the chunk. Let's just view this thing. Okay, as you can see, we have only the top 21 and we have other. So you can see the main producer distributor was HBO, the second NBC, CBS, ABC, and others. I don't need other category. Let's get rid of it. So I'll write filter, and I don't need that distributor is not equal to order. The same thing with producer. I don't want that producer is not equal to order. Okay, and we have this. Let's select distributor producer and type. Let us see how much they affect each other. Okay, let's pivot, do the same thing we did above, pivot longer, minus type. Okay, let we see. Okay, we have type, nominee, winner, name, distributed producer, and value. And let's sum everything. So summarize. Okay, by type, name, value. Okay, okay. Summarize. Why the summarize didn't work? Okay, count. Let's do count. Okay, count, but type, name, value. Okay, we have the count. So there were ABC had like as a distributor had 1,496 nominees, for example, and we can on this like make some graphs. So ggplot. Okay, and let us say that aesthetics, we need here, let me think, color, no, fill is type. Okay, name is the facet, so plus facet wrap name, scale is equal 3. Okay, and value is y and is x, so n value. Okay, and I need geom call. Okay, let us see what we'll get. Okay, oh, there are a lot of different producers here, and as you can see, let us. I don't want so many names, so but you can see it has some good effect on nominee or winner. We can see that, for example, ABC has more nominees than winners, and we can see that indeed, the producer and distributor have effect on that if the show will be a nominee or winner. For example, if it's Netflix, then the probability that it will win is quite negligible, for example, on the past data. So we can make this graph a lot nicer. Let us first of all say that let's do mutate and say that producer is equal to str string string replace no source split post start subset to lower to title trim screen trim, the same thing, producer, and the first 25 letters. This will make this graph more appealing. There is some error. Producer age must be it must be no vector. Okay, string trim. Did I use the wrong function? Okay, I did use the wrong function. Okay, let us see. String trunk. Maybe this is the function. Wait, okay, this is the function. Okay, truncate. Okay, as you can see, it gave us better results. I don't like NAs, so let's say that do we have NAs here? No. So is not NA. Not is NA producer, so we won't have any NAs. Okay, we have NAs here. Why do we have NAs? Producer, I don't want to be NA. NA. Maybe it's just written NA. Okay, producer doesn't equal NA. NA. Okay, let us see. Okay, that there is a, let's no, no, okay, let's don't how should I remove this NA? Let's count just count producer sort equals true. Where is NA? Okay, we don't have NAs here, as you can see. We don't have NAs here, but somewhere in the process, maybe here, somewhere in the process we are accumulating NAs. Maybe here. Okay, there are NAs here. So after count, I don't know why we are accumulating here NAs. After this thing, let's do the filter again. Filter. Note is NA producer. And let's make the code nicer. Okay. Okay. We don't have NAs. Okay. And let's give everything in percent. I want to do everything, like show everything in percent. Okay. Let's do that. So let's mute. Let's see what we have here. Okay, so distributor and other things. So I want percent to see the percent. Let's have everything in add a new column. So group by, let's say, type, and add mutate new column PCT, which equals n divided by sum n. Okay, we have a new column percent. So 16% from ABC were nominees, as you can see, ABC, and other something like that winners. But the other thing is here, like it's around. Okay. Okay, let's persevere. We'll see what we have. Okay, let's have ggplot and let's say PCT here. Let us see. PCT, it didn't. Okay, so there was something wrong here as I imagined. Okay, nominee, distributor, ABC. Group by value. Okay, I did the wrong grouping. Okay, it's more or less correct. So ABC is 68%, as we see. So on group will do. Then it will be here, and I expect to see 100% everywhere. So 100, 100. There is some discrepancies here. I don't know why. Okay, we'll come back to this formula to have more beautiful graphs. But right now I want to do machine learning. And machine learning takes some time. So let's do machine learning, and when we'll do machine learning, we'll go back to this code. Okay, so machine learning. Let's set seed. Okay. Set seed. Okay, 1, 2, 3, 4. Doesn't matter which number you write here. So it sets seed for randomness. So each time we'll get the same results. we need to split our database. Split. Okay. So split initial split globe clean, and I know that we are going to do a classification model based on types. So Cetera is type. We just say that we are going to split based on strata. So in each database, testing and training will have equal amount of like type. And this is our split. Then based on split, like split is just splitting our database. So this is our training. This is our testing. Okay. Based on split, let's say test train is equal to training split, and test is equal to testing split. Okay. On this, we'll have two databases. This will be the training database on which we'll do our models. This will be our sacred testing database, which we won't use until the end to prevent any data leakages and to see how our model compares to the real world. So this is our testing, and we need to do some cross-validation to train the model. So I'll set seed once again for 8. Okay, and cross-validation 3. I like to have two cross-validations, threefold cross-validation. We for CV train. This will help me to like train the model faster, and to finalize the model, I like to have a train fault cross-validation as well. Okay, this is our cross-validation. Okay, then let's make a recipe. Recipe is like the steps on which we are going to do our analysis. So we are going to write recipe, and in recipe we are going to predict the type. Okay, based on everything else. So dot means everything else, and our data is the train. Okay, and this is our recipe. So rec1 is our recipe. Okay, it isn't doing any training, and we don't right now. We aren't choosing our model because we can choose any model. Just we are making our recipe, and if we see what is in our recipe, it just say nothing at all, just our original data. And if we prepare our recipe and juice it, prep choose our recipe, we can see that it's just the original training recipe. Okay, in this training recipe, there are some things we can't use in machine modeling. For example, we have a lot of words we can use. So we have this thing, logo, which is just a hyperlink. So what we'll do, step rm remove. Let's remove logo. Okay, then let's step tokenize. Okay, nice. So everything we have, every word we have in each column will be tokenized. We'll see all nominal predictors. Okay, just tokenize all nominal predictors. Let's see what we'll get. Okay. As you can see, like every column we have tokenized. So, and like outstanding something, and we have 5 words here, and each word has a predictive power. So we aren't looking at sentences, at titles. We are looking at each word in a title and seeing how much predictive power each word has. So after that, I like to combine stop words are words that doesn't have any meaning and don't help us to predict anything. So we are going to stop words minus all predictors, all predictors. Okay, let's see if it run. Okay, it run. So as you can see, all column selected or this step should be token list. Okay, so okay, minus year. We don't need to tokenize year. Okay, minus page and minus page ID and producer. Where is type? I don't see type. Type fact. Okay, type is fact. That's fine. Okay, let's have this. And see what we have. All column selector this shape should be token lists. Year, page, and type. Minus type. As you can see, like we had here 5 tokens, so 5 words. The one word was the or something like that, and it was discarded. We had 8 words here in producer, so there was some words that there and another that was discarded. We don't want them in our predictions. So after that, I want to merge all the token lists. So step token merge and the same thing. I don't to merge like those things, and everything else I want to merge. Okay, as you can see, we have 13 tokens. So we had a lot of columns, and each column there were some words, and we can do like have a good prediction on just words. So we tokenize those sentences in those columns and merge them. So there are 13 descriptive words here, 12 descriptive words here. After that, we can step token filter, token merge column we need, merge. Okay, and say mean times is equal 8. That means everything that repeats less than 8 times should be discarded. We don't want to predict on that. So let us see what we'll have. Okay, so 4 tokens, 6 tokens, 4 tokens, 5 tokens. So there were additional 9 tokens here which didn't repeat much, so we discarded that. And after that, I want to step TF, okay, and let's say token merge, token merge, okay. This will give us the final columns. As you can see, we have right now like 104 columns. What happened? Just I could have made dummy variables for each nominal column, but I chose not to at this time. I just made a column for each name in our token list for each word. So if we just view this thing, okay, let us wait a moment. Okay, so 2020 Century ABC Academy. So the first nominee has two ABCs, so producer and I presume the producer and distributor. And for example, like, well, let me see, designer. So the word designer, this one has one word designer, this one has one word designer, and so on. So on this we can have some models, but machine learning models don't like databases that have a lot of columns. So to avoid this, the next step I like to do, like if we have a lot of columns like this, I like to do dimensionality reduction. In this case, we have a database that has 104 columns. So that means that our prediction, affects 103 other predictors. So we have a space with 103 axes, and we need to do some dimensionality reduction. Dimensionality reduction can be done in two major ways. The first way is matrix, using matrices. The second way is using topology. I'll use the main way to reduce our axis. So it's a matrix way of reduction, and it's called personal component analysis. So step PCA. It's a step of unsupervised learning. So everything contains TF. Everything that has TF relates to a dimensionality reduction and numcomp. So we'll have 10 rows, only 10 rows. Okay, let us see. So after this, and I chose this number randomly, so we can tune this number so it'll be the best. After this, we have reduced our dimensionality of 103 columns to 13 columns. So we have page ID, type, we have year, page, like the three main numerical variables we have, and on all the categorical variables on all the words we had, we gained PCA on which, like these numbers, we can do predictions. And let's see what those PCAs, let's say this is rec comp, something like that. Okay, let's see what's inside here, and we can do. Okay, let's have rec comp. What we can do? We can, let's pivot longer, pivot, the same trick we did earlier, contains PC, so everything that has PC in its name, then ggplot, okay, AS, aesthetics, RxS and YXS, so fill is type, and X is value, okay, and I want geom density, and alpha equal 8, or let's give 6, plus facet wrap by name, and let's say scales is equal 3. Okay. Error object value a value. Okay. Okay. As you can see, we have 10 personal components here. They are normalized, as you can see, -3 to 3, mainly normalized. They have more or less normal distribution, and we can see that they have some predictive power. So if PCA1 is from -2 to -1, we can say that it's more likely that it will be maintain a nominee. If it's from -3 to -2.5, we can say it's more likely that it's a winner. We can explore more and to understand what each PCA means. Let's combine our databases, because right now we just have like year, page, and our PCAs and nothing more to see. Let's use this, add a row number, because I know like we have like 22,248 rows here. The same thing is here in train. I want to combine these databases, but I don't have anything like any column that is the same here. That's why I know that each row, like this row, correspond to this row. That's why I'll just add the column, the row number in each case, and combine these databases to see how, for example, distributor affects each PCA, something like this. We'll do that like this. Mutate row, add, no, add row, no, let me row number. Let's say row. Now this is the function row number. Okay, we have added just row, which is the row number. Okay, and let's join left join the train database, which should have like this as well, like row number as well. And by is row. Okay. We have joined the two databases, so as you can see, we have the category, logo, production, everything on which we gained these personal components, PCAs. And on this, we can say, let's mutate distributor. Let's see how the distributor affects other things. So distributor, let's facet factor lump. Let's lump it. Okay, and let's say 20. So you remember this function, we lump it, so everything that repeated like isn't in the first 20 rows will be put in the category other. So pivot longer I'll do, and let's say we want to pivot longer PC this column, this column, this column, O4, and this column, O5. Okay, and let's make a visualization. Okay, ggplot. Okay, we'll do aesthetics. Okay, X is PC1, O1, Y is Y is value. Okay, color is distributor, and I would geom point, so scatter plot, and facet wrap by name. Okay. Okay, let us calculate. It will make some interesting graphs to for us to compare, to see what is going on. Okay. as you can see, there are a lot of colors. Uh, let's make it bigger. Wait a moment until it's load. This is the things we had. So as you can see, uh, okay, it's loaded. So as you can see, like this is like everything compared to PCA1, so personal component analysis 1. In PCA1, like I don't know, this is HBO. Like if it's less than, if PCA1 is less than, is more than 1, it represents HBO, for example, HBO. And we can see other stuff like how each personal component represents our data. If there is HBO, it's here, and other stuff we can see. So each personal component describe our data in each way. So we had words, we had numeric nominal data, we had data that like were represented with words, and on that we did personal component analysis, and on that, as you can see, we have some numeric data on which we can predict. Okay, let's do some predictions. Okay, so as you can see, we did personal component analysis, and we did some word manipulation to predict on words. Okay, on that note, let's us continue. Okay, let's us use baguette bag tree model. Okay, switch set engine with engine R part. Okay, and classification set mode class. I like Bag3 model. It's comparably fast than other tree models like Random Forest and XGBoost. It's much more faster, and classification, and it gives comparable results. Models are smaller, much more smaller. Bag. Okay, this is our model. Okay, we have our recipe. We have our model. Let's marry those things together. So we'll marry those things together using function workflow. So this will be bag workflow flow, which is just a container. It doesn't have anything in it. We just like put stuff in it. Add model, we'll say, and our model is bag3. Okay, and add let's see, recipe, and our recipe is rec1. Okay, bag3 not found. Okay, let's run this together. Object bag3 not found. Bag3 backspace. Okay, backspec. Okay, and as you can see, this will be our model. It's just a container. It doesn't do, right now we don't do any machine learning. It's just a container that says our processor, our model is bag3. We use some recipe. These are the 7 steps of our recipe to make the data on which we are going to do our prediction. Okay, and we have done the specs. We can do the prediction. Okay, let's tune our model. I haven't written anything here to be tuned, but I want to tune this thing. So I've just written that we have now 10 principal components. Let's tune it. Let's see which amount of principal components gives us the best result. Okay, let's say, okay, tune. This is the thing we are going to tune. So globe tune, like our tuning, is equal bag workflow we have, which is going to go to tune grid. Okay. Air samples. Okay. Object. Let us F1 see what must be here. Workflow tune. Okay, processor and air samples. Air samples is cross-validation tree. We are going to tune our model on this thing. Matrix. Matrix is equal to, okay, metric set. This is the main metric on which you are going to tune. There are a lot of different metrics, but when I'm doing a classification model, I like to use ROC AUC. So as you can see, there are a lot of things we can use. Here are the we can use accuracy, a lot of different things to like base or on our model. So mean square error, for example, where is mean adjusted error, mean different things, mean square error, something like that. But if we are going to train on classification model, in this step I like to use just ROC AUC, okay, without parentheses. Okay, this is our metric set. Then control, which will equal control grid tune, and let's say save prediction true. Okay, this is the only thing I want, and let's continue. I want to I need the grid, the only thing, crossing, which is interesting and good function to use in a lot of cases. It's very interesting. And say lamp comp is equal to let's say 15. Okay, and before we'll do the we'll train our model, I like to write start equals sys time to see how much my model takes time, and here write finish, and print it. So print finish minus start. Okay, and let's tune our model. Okay, it's doing tuning to see how many number of components in principal analysis, like in how many principal analysis will give us the best model to use. And let's before as it's doing this thing, let's us auto plot, write some let's write some code. We want to auto plot globe tune after it's finished. While it's doing it, machine learning, some machine learning, I want to go back to this thing and make it more pretty, like this. And for it, I need a new instance of R. So I'll open a new instance of R. make this more prettier, and I think we'll finish after I'm done. Okay. Okay, this is our new instance of RStudio. Okay, let us new file R Markdown. Okay, and I'll copy everything that is here because right now this instance of R is doing some machine learning. We won't be able to use it for some time, so let us like in this instance like no, in this instance chunk output in console, remove output. Okay, download the database. As I remember, it took some time to download this database. Let us wait for a second before it's doing the machine learning here. Okay. I've just copied like the code we have written in a new instance, so we can make this graph more appealing before like the main instance of R is doing machine learning. Okay, it's right now the second instance of R is downloading the database. Okay, it's downloaded. Let's do the main steps we have done. So something like that. Okay, we have done some grants as we can be seen here. This graph is good, and I wanted to better this one. Okay, this one. And when I've done group by, let us come back here. Okay, I have so gained some data, and based on this data I have some discrepancies. So distributor producer, I want to not only group by value but also by name. Okay, I think this will solve our issue. Okay, this had solved our issue, so everything is fine. So as you can see, like we have 100%, and in this, like if it's Prime Video, it's more likely to have winners. If it's to have win, and if it's Comedy Central, it's more likely to win. Let's like if we want to have like better graphs, let's say that like let's change the color. So scale, fill, let's say brewer. I think it will be nice. Okay, it's nice. Okay, and let's change like here some stuff. Let's say mutate and let me see, PCT, no, value value is equal to FCT there is I need a new library. It's called tidy text. I need the library tidy text here. Tidy. Okay, where is tidy text? Let's call upon that library. Library tidy text to make this thing more appealing. So in this library tidy text, there is a function called fc. No, there is a function tidy text unless tokens tidy scale is square ordered. Okay, not this function. but reorder within. Okay, I need this function, reorder within. Okay, and I need something like this here because those two functions work together. Okay, and I need to say reorder within function. Okay, x, by, and value. So I'm going to reorder value by type, no, by name, and value is PCT, if I'm not mistaken. Okay, and let us see before adding this last step, PCT not found. Okay, PCT reorder within, within, by, within. Okay, let us see. Within vector of list of vectors, the same like that will end the list of vectors. Okay, by. Okay, I need to change those two. Name not found. Ah, I've forgotten to write pipe. Okay, MVC, it didn't give me the result I wanted, so I think I need a function because I'm using the percentage. So function is right now mean. Let's say function is, so the average is minimum. Okay. Okay, it gave the result I wanted. There is some issue here, but let it be. And let us add this thing. Okay, but Y reordered, so Y reordered. Okay. And let us add before let time. Okay, it's finished in 5 minutes. As we can see, it's a lot of time, a lot longer than I have expected. I think there are a lot of processes running in background for machine learning, but let us see our results. So as you can see, the best result with very high area under the curve gives us 4 PCA, so we can expect to have the best result, the best model with this thing. So we are going to just say that we are going to use 4 here. Okay, 4 principal components is enough to give us a good estimation of our model, to understand what is going on. So so as we can see, and our model has a great predictive power to understand if it's nominee or not, because we have a high ROC AUC. We are going to use it later, but let us add here some labels, labs, and say that X is per like probability of winning, probability of winning. Okay, I don't need Y, Y, okay, and let's have a title. Title is like okay, let's don't have like probability of winning. Given the production and distribution. Okay, that will be it. Okay. Okay, we have some interesting, very appealing graph we can share. As you can see, like it's more probable to be a winner if you are from Comedy Central. So it's more than 35% probability that your show will win a nomination. Prime Video. If the producer is Central Production, Amazon Studios, that does have a high probability as well. And I want to copy this and paste it in our main chunk here. Okay, let me see. Okay, we have discussed I think I'll finish on this. We have discussed how we this database. We have made some interesting graphs on this database. So as you can see, what is the predictive power of our page ID, so our numeric values, which is the prediction power of our two of our some errors, column mutate, why it gave us error, column mutate, column value, error the retain could not find function because this instance of R doesn't have the library tidy models. Okay, that's why we have the error. Okay, how much a problem with mutate column value of the retain could not function. Okay. Tidy models. Okay, how much predictive power each of our, let us go back, how much of predictive power each of our main two nominal column set, so distributor and producer. As you can see, it had a lot of predictive powers. Then, as you can see, we did some splitting, training, and testing. Did some stuff here, tokenized our nominal variables, made the stop words, and made a principal component analysis. Trained our model on Backtree and found out that if we have 4 principal component analysis, principal components, our model will be best. And we trained our model. We didn't compared our model with testing database yet, but I think I'll finish on this today. Thank you for watching.